We have already surpassed the 400 ppm of carbon dioxide in the atmosphere. This is having consequences for the planet through the global warming. In this context, helping to protect and promote those ecosystems that are able to capture and store carbon dioxide in the form of organic carbon is a smart strategy. Coastal vegetated ecosystems, such as salt marshes, mangroves and seagrass meadows, happen to accumulate important amounts of organic carbon for hundreds to thousands of years. This carbon is known as blue carbon. Within the framework of the Life Blue Natura project, we thought it was timely to organize an international course to transfer all the knowledge we have acquired over the years to help other research groups to get started in the blue carbon world. We were quite surprised when after only 3 days after opening the call of the course, it was fully booked, even if the deadline for registrations was still a month away. Applicants come from all over the world, from Indonesia, Tunisia, Kenya, Sweden, Canada, Germany, Portugal, well, Italy, Spain, from everywhere. So I think it's become obvious that there is a high interest out there in learning the concepts and techniques needed for blue carbon research.
Research over blue carbon ecosystems can be very complicated due to the high spatial variability we found in the field, and this can be a problem when we try to standardize methodologies to develop projects for estimations of stocks and fluxes. The researchers that are currently working over this are trying to establish the same methodologies so all the results can be comparable, but those methodologies are constantly improving.
When planning the design of a blue carbon inventory project, we will face multiple challenges because there's a large variability in the blue carbon ecosystems that implies extensive field work that requires careful organization. There are thousands of samples produced to be processed, to be analyzed in different parameters, and all this requires very rigorous organization. When one takes a look to the thematic maps generated to present the blue carbon stocks and fluxes, it is difficult to imagine the gigantic work behind those colorful areas.
The large differences in the stocks and fluxes of blue carbon that we measure in the field are the consequence of the interplay of multiple factors. For example, the features of the terrestrial catchment close to the blue carbon ecosystems, the type of substrate where the plants are growing. For example, the substrate can be carbonatic or siliciclastic, and the grain size can vary a lot. Also, the water depth column and the elevation of the salt marshes, and of course the anthropogenic disturbances. All of these are just some of the many factors that can explain differences.
The interest in blue carbon research has increased exponentially since around 2009, after the publication of the report by Nelman and collaborators. The blue carbon community is currently publishing over 300 papers a year. One of the main drivers of this spectacular expansion is probably the fact that the carbon stored in the sediments of this blue carbon ecosystem is pretty significant, and that can be used and can be helped to mitigate global warming and to help us to conserve this blue carbon ecosystem.